So it has ends of isosceles triangles that are 3 feet across and then have a height of 1. And they tell me that the trough is 10 meters long, so this thing goes back 10 meters. Ooh. Oh, 10 feet, 10 feet. Everything's in feet, so we're okay. If the trough is being filled with water at a rate of 12 feet cubed per minute, so the change in volume with respect to time is 12, and they want me to find how fast the water level is rising when the water is 6 inches deep. So if I draw in my water level is here, and they want to know how fast the height of the water is changing, so they want me to find dH dt when the height of the water is 6 inches deep. 6 inches or 6 feet? 6 inches, which is half a foot. Tricky. Alright. Cool. So we need to relate all this stuff. They tell me about volume, so I need the volume of this trough. Now this trough is a prism with a triangular prism. So the volume is the area of the base times the height. Now the area of the base is, let's see, I want the volume of the water, right? So I need this length there. So if I call this little part x, then the area of the base is going to be, the area of the triangle is 1/2 the base, which is 2x, times the height, which is h. So 1/2 the base, which is 2x, the way I've labeled it here, if that little part is x, times the height of the trough, which is h. And then this height is the height of the actual trough itself, which is 10. So kind of poor notation that I've got 2 h's there. This one's supposed to be the height of the trough, and that h is the height of the water. But this is your formula for your volume, and if we clean this up a bit, the 2's will cancel, and we just get 10xh. And when I go to differentiate, I kind of want it in respect to just one variable. So I'm going to try to find a way to relate my x and my h. I'm going to do that with similar triangles. So I know that this length, the 3, is to the 2x as the height of the whole thing. The 1 is to the height of the water h. So this length is to that length as this height is to that height. And so I can solve for one of these. I think I'd like to solve for x. So I've got 2x is 3h, so x is 3h over 2. So when I plug in, I have the volume is 10 times 3h over 2 times h. So if I clean that up, now it's all in terms of h, and that's what they want me to find, right? dH dt when h is 1/2, so that's nice. So this is going to be 15h squared. And now I want to find dV dt. So dV dt, just take a derivative, that's 30h dH dt. And I want to find this when h is 1/2. So this is 30. Oh, I want to find dH dt. So, it's fine. So I can plug in dV dt is 12, and this is 30. H is 1/2, and I'm looking for dH dt. So just solve this guy. This is 12 equals 15 dH dt. So dH dt is just going to be that 12 divided by the 15. If I divide that by 3, I get 4 over 5. h dt is 4/5.